Hi everyone. Today we are going to introduce a special topic, topological sorting. It's basically a way to line up tasks or events in a right order when some things depend on others. Imagine you're planning a project, cooking a complicated recipe, or even figuring out which classes to take first. Topological sorting helps you figure out what needs to come before what. In computer science, we use it to work with directed graphs and make sure that all dependencies are respected. It's a really handy tool whenever you have a bunch of things that need to happen in a specific sequence. All right, that's basically about what topological sorting is. Let's get started. Before we start, let me ask you a quick question. Have you ever followed a recipe where some steps must happen before others? For example, you have to boil a pasta before you mix it with the sauce. Right? That's the two things that cannot happen simultaneously. This idea, where some actions depend on others, is actually a key concept in computer science. Today, I'm going to introduce a term called topological sorting. Again, let's look at this quick example. In the bottom, there shows a graph. We need to familiarize ourselves with two concepts that forms the fundamental of topological sorting. In the next few minutes, I'll cover three main things. First, what topological sorting is, and second, how it works with a simple example, and third, why it's useful in both computer science and everyday life. Let's go back to this graph again. There are a collection of nodes and arrows. Each arrow represents a dependency. This idea that one thing must happen before another is actually very important. For example, in the bottom left here, the nodes A points to nodes B. What does that mean? It means that nodes B has the dependencies on nodes A. In other words, nodes A must happen first before nodes B. That is an illustration of what dependency is. Here's the formal definition. A topological sort is a linear ordering of the nodes in a directed acyclic graph, also called a DAG, such that for every arrow from node U to node V, U must appear before V in the final ordering. However, notice that we don't allow cycles. For example, in this case, if there's another dependency from node D to node E, then the three nodes shows up right. DCE forms a cycle. It's basically saying that node D depends on node C depends on node E, and node E depends on node D again. A cycle is impossible to solve. A cycle of tasks are impossible to schedule. Therefore, we, by definition, rules these cycles out. We don't allow that. We simply don't deal with cycles. Okay? Now, let me explain how topological sorting actually works with a simple example. After that, I'll talk more about its applications. Suppose we have a topological graph here. You can see all the nodes and their links. There are a total of 5 nodes, A, B, C, D, E. And there are many links between the nodes. So the first step is to find a node which has no dependence. In this case, the node A. We put A at the beginning of the ordering, and then we remove all the relevant links. Now, look at this reduced graph again. Once again, we need to find a node with no dependence. At this particular step, it's obviously node B. Same operation. We move B next to A and remove all its links. Then we repeat the same process for all the remaining nodes. Node C, remove the link, and finally, we're left with only one node. No doubt about it, that's our final element of the ordering. And done. We just completed a topological sorting. It's just as simple as that. I hope everyone has learned how to do topological sorting. Next talk about its applications. Topological sorting is everywhere. We use topological sorting whenever we need to order tasks that depend on each other. It appears in course scheduling, social network, and recommendation system in any shop websites. For example, at USC, we need to take class 201, but it has a prerequisite called course 101. So we need to take course 101 first before we take course 201. These kind of dependencies can actually be dealt with topological sorting. Here's another example, social networks. For example, a friend A is a friend of B, who is also a friend of C. Then this kind of relationships forms a social networks. If I was a new registered user at Facebook, I'll be the root node. That means I don't have any friends, I don't have any links. But once I friend other users on the Facebook, I create the link between us. These kind of relationships can be useful for friend recommendations and many other things that can happen building on these social networks. There's other applications too. For example, recommendation systems. That user A likes some kind of sport and another friend of him also likes sport. This kind of relationships can form a topological relationships. So, understanding topological sorting has a practical applications every day, even without knowing it. To summarize, topological sorting orders tasks with dependencies. It works only with directed acyclic graphs. It appears in course scheduling, project planning, and software development. And it has many valid applications. As long as all the dependencies are respected, there will be a solution. I hope this helps you see that topological sorting is not just a theoretical idea, it's something that you use every day. without realizing it. Thank you for listening. I'm happy to take your questions.